Good afternoon. This is Kai Lee. I'm with UFI Space here in San Jose. I'm going to spend the next 10 minutes to talk to you about some of the latest development technology, not only on the telco space, on the carrier space, but also on the mega scale data center. And with some of the use case that we are building, and we're also demonstrating some of those at the OCP Experience Center. So just a little bit about the company. It's a Taiwan-based company headquartered in Taipei. I work locally here in San Jose and run the business here in the US. And we do have a number of carrier customers in different parts of the world. All right, so this is kind of the data center trend. Yesterday, one of the presentations, we talked about how you build a data center today is quite different than how you build it in the old days. And I define old days like 3 years ago or even 5 years ago. Back then, there was a lot of emphasis on port speed, density, data center interconnect, load balancing, disaster recovery, things like that. But now, as some of this trending that we are seeing, the data that we are getting from light counting marketing research, there's quite a bit of the AI element into the equation. So in a second, we're going to kind of share with the audience some of the boxes, some of the solution that we are building, how we incorporate into some of this newer intelligence into the equation. All right, so this is kind of like a showcase at the Experience Center, like right behind you. For those of you that are interested, we kind of have like a different scenario of showcases. We got the good old traditional, the spine leaf routing switching, and that is based on the good old Broadcom XGS. XGS, for those of you who are kind of in this space, those are the Tomahawk and also the Trident. And they are kind of positioning this in a very interesting way. The Tomahawk is really like speed throughput. The Trident is kind of compromising a little bit on the speed, but will give you some feature and capability on the programming. All right, so that's traditionally how the data center space is being positioned. At our Experience Center on the back, we are showcasing some of the latest one, like the Tomahawk or the Trident 5. Those are some of the latest chipset with some of the latest feature. And then you'll be able to take a closer look at some of these newer chipset that they are at the 5 nanometer. I'll talk about why you care the chip is 5 nanometer versus they are 16 nanometer in a second. And then at the Experience Center, we also have some showcasing of the AI and the machine learning. And those were being powered by some of the latest development of the Jericho 3 and also the Ramon 3. Now, why do you care about J3 and Ramon 3? It sounds sexy, you know, you talk about all these latest chipset. But we really want to bring to the equation of the use case. So one of the biggest use case when you build the latest, greatest with the Jericho 3 merchant silicon, what means for you is now we can have a high density support of the 400 gig fully populated and migration to the 800 gig, especially using some of the coherent optic, the CR, CR+, things like that. If you're in the carrier space, those are particularly important because of such a long distance. You can get rid of some of the intermittent boxes, you know, like the ROADM and things like that. So we are doing a lot of those type of testing with our carrier. So J3 is great, switching at 14.4, switching backplane, a 5 nanometer chip. But what is for you as the audience, when you deploying a box with Jericho 3 and Ramon 3, is giving you the capability of doing a fully populated 400 gig port design at high density with the migration to the 800 gig. I'll talk a little bit more about like the latest coherent optic, how we solve the problem of the heat dissipation, power consumption, so we can fully populate the entire box with those optics. All right, so this is a picture our marketing team put together. It's right behind you. For those of you at lunch, you want to take a look at it. All right, this is where the rubber meets the road. All right, so we are bringing, showcasing some of the latest one that we were talking about. So kind of starting from the bottom to the top. So we are showcasing the Trident 4. Trident 4 has been around for probably a little bit of time. And then also on your left-hand side, that's the Jericho 2C Plus and the Ramon. So that's kind of the existing generation. Jericho 2 came out in around 2018, 19, something like that. That was switching at 4.8 terabit per second. 4.8 terabit it was a pretty decent size to build a high density 100 gig port, and then an okay size to build 400 gig port. If you do the math, 4.8 terabit, you can have a 40 port times 100 gig that give you 4.0 terabit. We had to have some overhead to support like the TCAM and all that. And if you reverse the math at 400 gig, you can only go up to 10 port. The J2C Plus basically go 150% of the J2, which is a 7.2 terabit per second. The box we are showcasing here to show using a dual chip design, 7.2 times 2 is 14.4. That is a dual chip design. We can bring up to 36 port of 400 gig for those of you who need a 2 RU spacing, but still have a much higher density of those. So this is kind of from the bottom up. So we're showcasing you the existing generation. And as we are getting more and more into the newer use case, okay, everybody in the show for the last 3 days talk about this, okay? So I don't need to repeat where you've been hearing. But the bottom line, the trend is coming. There's a lot more things that need to be connected with this kind of intelligence. So that take us, and a lot of these, we drive you to pay more attention to the 400 gig, regardless you are using the QSFP double density or the OSFP optic, which has a better built-in heat dissipation. If you look at the OSFP optic at 400 gig, you actually are seeing a built-in heat sink. So that's why in some of this magic, we were able to fully populate the entire box with 400 gig optics and take care of the power dissipation and also the heat dissipation. So I'll talk a little bit more about that. So this is the kind of the latest and greatest. We talk about the J2, we talk about the J2C Plus as an interim. Broadcom, I believe last quarter officially announced this. I think they are showcasing some of those at the show today. We are one of the early adapters working with Broadcom in Taiwan, and we have already built the Jericho 3 and the Ramon 3. To put it in a nutshell, J3 switching at 14.4 terabit per second is a perfect use case to design a box with the 400 gig high density. And we figured out the different way to solve the problem with the heat dissipation, the power consumption, and our box actually can support quite a high density as we label here. On the other side, we are showcasing the Ramon 3. If you're familiar with the DNX technology, it's a packet to cell to packet switching to make up this thing called the cluster. The entire thing works like a virtual switch from a network management perspective. So joining the J3 family, the Ramon 3 also came out. This one can support up to 64 port high speed 800 gig / 400 gig switching for cell to downlink to all the Jericho 3, including the Jericho 2 and the 2C Plus. So all these things we are building has the mindset of backward compatibility. By the same token, on this side, the Tomahawk 5, that is on the data center side, is also the latest one that we are working on to build this box. If you remember what I said about a couple minutes ago, that when you look at the XGS, the Tomahawk, the Trident, you know, all named after all these missiles from the submarine that they shoot out. So the chip named after those. So the Tomahawk basically focuses on high speed, super high speed throughput. And if you compare it to the Trident, it's kind of like compromising a little bit, but they give you some programmability, some feature set and all that. So the Tomahawk 5 we are showcasing here, and the Jericho 3 on this side, those are some of the latest ones, you know, with the 5 nanometer technology. So one last thing I want to leave with you, why do you care about when somebody tells you, I'm buying a box with a 5 nanometer chipset? Some of the Jericho 2, I want to give you an idea. J2 came out in 2018. That is a 16 nanometer technology. And now we are down to 5. A 30-second explanation on why you care 5 nanometer is two things. One, we can lower the power consumption per processing unit. Two, because the nanometer is getting smaller and smaller between the gate on the wafer, you can stuff more and more intelligent on the same surface area of the wafer. So you can expect the same chip at a 5 nanometer can provide you much higher computing power and then the power consumption per processing, per megabit of processing is also lower. So those are the two things that's kind of take away, and I'm sure there's a lot more things there in the chip design level, but at least in a short lightning talk today, I want to kind of share with you why you care with that. All right, so call to action, last thing, we have a whole rack. We have 3 racks behind the scene at the Experience Center. You cannot miss it. You walk there, you look for the blue, the purple color cable, and you kind of see the 3 rack we just showcasing you. Has all the boxes that we talk about today. So enjoy your lunch, and hope you come by and say hi to us. And I'll be around if you have more questions. We can talk a little bit more about the box. Thank you.